everybody. Can you guys hear me? Good? Cool. Yeah, so as Sean said, my name is Cadamwathan. No real time for pleasantries. We got a lot of code to get through. So today I want to talk to you guys about curing the common loop. So has anyone ever written code that looks like this before? Or at least worked with code that looks like this before? And hated working with code that looks like this before? So the goal of this presentation is to teach you how to never have to write code that looks like this ever again for the rest of your life. So to do that, we need to talk about some fundamentals. So I want to talk to you guys a little bit about higher order functions. So a higher order function is a function that either takes a function as a parameter or returns a function or even does both. So there's something that you work with very often in Laravel. For example, when you're defining a route, like a closure-based route, the get method on the router is a higher order function because it accepts a function as a parameter. Or when you're sending mail, so the send method or the queue method on the mailer class is also a higher order function because it takes a function as its third argument. Or a database transaction. It takes a function as an argument, and that's the code that you want to run within the transaction. So they're very useful. Now, they're the sort of thing that you work with a lot, and you maybe use a lot in other people's APIs, like a lot in other people's APIs, like especially if you're writing lots of JavaScript, callbacks everywhere, constantly, all the time. But there's something that took me a couple of years to really fully start to appreciate the power of when designing my own APIs and writing my own code versus just kind of using them in other people's code and sort of thinking I knew what the benefits were. So the reason that higher order functions are powerful is because they afford more powerful abstractions, stuff that you can't do when you're just working with values as parameters versus bits of code that you can pass around. So for example, here's a snippet of code that takes a list of customers and converts that list of customers into a list of their email addresses. Has anyone seen this pattern in their code before, where you start with an empty array, loop over something else, stick stuff in that empty array, and then eventually return the new array that you built up? Yeah? A few people? So here's another piece of code where we are trying to determine, maybe we're trying to build a report around figuring out what the value we have on hand is of different products in our store. So you can see we're looping over inventory items, and each item has like a product name, it has a quantity, like how much we have on stock or in stock, and it also has a price. And we're putting together this little data structure that kind of tells you what the product name is and the total value that we have on hand of that product, right? Now, if you look at this piece of code, the only thing really unique about it is this part here where we're extracting the email from the customer, right? And if you look at this piece of code, it's kind of the same thing. The only thing really unique about it is this stock total data structure that we're putting together. If you take the rest of that code, like the stock totals, the inventory items, and the stock total object, and you generalize the names of everything, you end up with something like this, where you have an empty results array, and you're iterating over items, and you're doing something with that item to create a result, and sticking it in that result, then ultimately returning these results. We can do the same thing with the other piece of code that we had, and now we have two pieces of code that are more or less identical, right? Like the only thing that's different is this little grayed out area. Other than that, everything is the same. So how can we generalize this? How can we create an abstraction around this? Well, normally if you have two pieces of code, and in those two blocks of code, there's maybe some code that's the same, what you would normally do is like extract that out into a function, right, to avoid that duplication. So you have some function that centralizes that bit of logic, and you use that function in two places, so you only have to update it in one place. Like normal named functions are really good for extracting duplicated pieces of code. In this case, we're kind of working in the opposite situation. We have two pieces of code that are almost entirely the same, and we want to extract out one piece that's different. And anonymous functions are really good at doing that. So if we take this little piece of code here where we're extracting the email from the item, and we extract that out into a callback that takes the item and returns the email associated with that item, and replace the code underneath with just executing that callback and passing in that item, we can do that exact same thing with this example. And now we have two pieces of code at the bottom that are exactly the same, and we've parameterized the difference to those two pieces of code. If we take this piece of code and wrap it in a function, we've essentially implemented array map from first principles. So now if we take this loop code here where we're trying to extract those customer emails, instead of creating this initial empty array and building it up by stuffing the items emails into each one, we can replace that with just a call to array map that just takes that array of customers and maps it into an array of that customer's emails. We can do the same thing with a stock totals example. We just take this whole loop and replace the entire thing with a call to array map where we return that data structure. Another one. Has anyone ever seen code that looks like this before, like this general kind of pattern where you start with an empty array, you iterate over some items, you check some condition, and if some item satisfies that condition, it gets put in the new array, but if it doesn't, it gets left out of the new array, and then you return that new array at the end. Seem kind of familiar? So in this case, we're trying to figure out what products are out of stock. So we start with an empty out of stock products array, loop over our products, check to see if that product is out of stock, then we stick it in the out of stock products array. If not, we just ignore it, and then ultimately at the end of the day, we return that list of out of stock products. Here's another really similar example where we're trying to figure out what are the expensive products in our system. So we start with an empty array, we iterate over the products, we check to see is this product more than $100 or 100 euros? If it is, we stick it in the empty array, build that up, and ultimately return that at the end of the day, so we have a new array that's just the products that cost more than $100. So similarly, if we generalize the names of everything except the piece that's kind of different in each one, we end up with code that's exactly the same except for the contents of this conditional, like the actual condition that we're trying to verify. The only difference is in this one, we're checking to see if the price is greater than 100, and in this one, we're checking to see if the item is out of stock. We can do the same work to extract that into a callback, execute the callback inside the loop, and now we have two pieces of code that are, again, exactly the same, except for what's being passed in through the callback. So now that we have two pieces of code that are exactly the same, we can pull that out, wrap it in a function, and we've implemented array filter from first principles. So if we take this example, the out-of-stock products, where we're doing it in a loop, we can replace that with just a call to array filter where now instead of having to duplicate the specification of how we're doing the iteration and all that stuff, the only thing that we actually have to specify is the condition that we need to satisfy in order for this item to be included in the new list. Same with this example. We get to remove everything except the one piece of code that mattered for what we were doing. And now we have like a generalized abstraction built around this pattern that we can reuse in different places instead of kind of duplicating that iteration code all the time. But what about an example like this? So this is a little bit more complicated. So we're trying to get the email addresses of the employees in the sales department. So we start with an empty array of emails, we loop over all the employees, we check to see if the employee's department is the sales department, then we want to add that employee's email to our list of email addresses, and then ultimately we return them. So if you look at just this piece of code, this looks a lot like map, right? Very similar to the map operation that we created earlier. But this piece of code here kind of gets in the way and prevents us from using map. If we were to try and use map in this situation, it would give us the emails of every single employee, not just the employees in the sales department. So how can we get around that? When I run into a situation like this, the first thing I try and do is figure out how I can solve this problem in more discrete, independent, small steps, right? And my thinking process is something like, well, I said to myself, I can't use map in this situation because if I used map, it would be applied to every employee, not just the employees in the sales department. I can kind of flip that kind of negative idea around into, well, I could use map if I was only working with the employees in the sales department. So how can we change this bit of code a little bit such that we can get ourselves in a position where we're only working with the employees in the sales department? Well, that sounds like a job for array filter. Oh, all right, there we go, still good. So now we can filter out any employees who are not in the sales department, and now we have a list of sales employees that we're going to store in this new variable. And now if we look down at the code below, we can replace our reference to all of the employees with a reference to just the sales employees. And now this conditional becomes totally redundant because we already know that we're working with employees that are in the sales department, so it can go away. And now we can look at this loop at the bottom, and all of a sudden we realize, hey, this is array map. We can totally replace this with array map. So we take that loop, swap it out with a call to array map, where we're just mapping all of the remaining employees into their emails. And now we're left with this solution. which no longer has any loops or any conditionals, which is kind of cool compared to the original solution that we had. So I want to take a little bit of a break here to talk about some things that I hate. The first is for loops, if you haven't gathered already. I hate for loops. The second is conditionals. I hate conditionals. And so far we're doing a good job of avoiding both of these two things that I hate. But the third one is temporary variables. Some of the cornerstones of programming: for loops, conditionals, and temporary variables. If we look at this code that we have here, we have no loops, no conditionals, but we have not one, but two horrible, evil temporary variables. So how do you get rid of temporary variables? Well, a common refactoring that you can use to do that is called Inline TEMP. And basically the way Inline TEMP works is you find every reference to a variable, and you replace that variable with the value that that variable was holding. And this works especially well in situations where you only are using that variable once, because otherwise you end up with duplication, right? Now in this case, the only place that we're using the emails variable is right at the bottom here where we're returning it. So to inline that variable with the value that it's holding, all we have to do is return the array map result directly. And now that emails variable completely goes away. Now, sales employees, the only place we're using that is as a parameter to array map, right? But if we try and inline the value of sales employees, which is the array filter call up here, we end up with code that looks like this, which to me isn't super great. It's a little bit confusing. And the reason that I find it confusing is because we want to filter the employees and then map those employees into their email addresses. But that's not what our code looks like it's saying at first glance. Our code says map, and then below it, it says filter, which is a little bit confusing. Like, that's backwards to how we're actually trying to apply these operations. And I want to talk a little bit about why that is. So this is something I call the problem with primitives. And I'm going to show you an example using strings instead of arrays. So here's a function that takes a snake case string, like hello there, Laracon, and converts that to a camel case string. And looking at this at first glance is pretty confusing, right? Like, what's happening here? What's getting called first? What's getting called last? What's parameters to which? And the way this is working is first we're calling stir replace down on the fourth line there, passing the result of that to UC words, passing the result of that to another stir replace call, and then passing the result of that to LC first, to lowercase the first character. This takes a little bit of time to grok if you're just looking at all these nested function calls. And the reason for that is that you have to kind of read it inside out. You have to start at the beginning and kind of count the parentheses until you see a closing one, and then you know, oh, okay, so this is the first thing that's being executed. And that gets passed to this, which gets passed to this. It's hard to follow. Compare that to this kind of make-believe version. Imagine that strings in PHP were objects that had methods. We could take the snake string, we could replace the underscores with spaces, then we could uppercase the words, then we could replace the spaces with an empty string, effectively eliminating the spaces, and then lowercase the first character. And that would give us our camel case string. To me, this is a lot easier to read and a lot easier to follow than the version that we looked at before. Now, it's hard to do this with strings in PHP, but it's definitely something that we can do with arrays. And we can do that using collection objects. So collection objects are an object designed to wrap around an array to expose the operations that we can perform on that array as methods on the collection. And Laravel has a great collection class built in that you probably run into a lot when you're working with Laravel. Like, anything that you get back from Eloquent comes back as a collection. Anything that you get back from the query builder, even in 5.3, is a collection. You run into them a lot. They're really cool. So let's see how using a collection would have changed this code. So let's look at this first piece here where we're taking our employees and we're passing it as a parameter to array filter along with the operation that we want to use to filter. Instead of taking employees and using it as a parameter to a function, we can treat employees as an object and call filter as a method directly on that employees collection. And that's going to return that array or a collection of sales employees. Looking at the array map call, we can do the same thing. Instead of passing sales employees as an argument to array map, we can call map on the sales employees collection. This will return a collection of the emails. Now if we try and do that same inline temp refactoring, we end up with code that looks like this, where we're saying, take the employees, filter them down to just the employees in the sales department, and then map those employees into their email addresses, which is a lot easier to follow than this example, where everything is kind of in backwards order. And you can imagine how much worse this gets when you start dealing with more than 2 operations. And compared to this solution, it's kind of cool because there's no details about loops, there's no details about conditions. Instead, it's just kind of an expressive, declarative way to say, filter out any employees that are in the sales department, map those employees into their email addresses. Kind of cool. So enough with slides, let's write some real code. So I have a little Laravel app set up here where I've got some code that I want to refactor using this collection pipeline style into something a little bit more expressive, hopefully free of loops, conditionals, and temporary variables. So this is that piece of code that we looked at in the very first slide, right after I kind of introduced the talk. And I'm going to spend a minute here to kind of explain what it's trying to do. So the goal of this piece of code is, given some employees that work for this company, where each employee maybe works in a different district and each employee serves some group of customers, we want to figure out which customers that were served by employees in the Amsterdam district, how much total sales did our best customers bring in? So how much money did we make from our customers in Amsterdam who placed at least $75,000 worth of orders? And you can see it's like kind of this gross nested shape with lots of temporary variables and kind of hard to figure out how it really works. So if we go to the browser here and refresh this, you can kind of see this is kind of our benchmark. This is the number we're going to be comparing against to make sure that we're not making any mistakes or screwing anything up. And I have another route down here. This is the great route, whereas this one is the grim route. So we're going to go from grim to great in this presentation, where I have that same implementation, but we're going to slowly refactor it and hopefully returning the exact same result along the way. So how can we get started here? And as we go over this, we're going to talk about a lot more operations than just filter and map, and I'm just going to kind of introduce them as we go and talk about them a little bit, and it should be fun. So looking at this set of nested loops and conditionals and stuff, what is kind of the first thing that sticks out to me that I would want to try and fix? The first thing I see is this conditional here, right? We have all this code here, kind of like the real meat of the logic lives deeply nested down inside of this function. It's only being run if the employee that we're iterating over is in the Amsterdam district. So one way that we could kind of try and remove some of this indentation and remove some of this, complex logic would be if we could figure out a way to only be dealing with employees who work in the Amsterdam district in the first place. So that sounds like a job for array filter, right? So why don't we do something like Amsterdam employees equals employees filter. And this is going to take the employee. And then we just need to specify the condition that's going to verify that this employee is in the Amsterdam district. So we can just return employee district equals Amsterdam. And if we dump that out, just to kind of make sure that we didn't make any silly mistakes, we can hopefully verify that we only have employees in the Amsterdam district. So we have 6 employees, and it looks like this guy's in the Amsterdam district, so I think we're okay. So now that we are working with employees that are only in the Amsterdam district, we can simplify some of this code here. So instead of looping over all of the employees, we can just loop over the Amsterdam employees. I always want to capitalize that D for some reason. And we can, Amsterdam. We can get rid of this variable assignment here and that condition. And we can pull this out a little bit. And if we refresh this, get rid of that dump, it looks like we still have the same amount, the $2.9 million. So what's the next thing that we can do here? So the next kind of piece of indented code here, it looks like we're trying to get all of the customers of an employee and then loop over those customers and do something. I don't really know what yet. So how could we kind of get this code out of here? Well, it looks like it might be easier if we had just a big list of the customers. Like if we had all the employees and all of their customers put into one big list, then we could just iterate over all those customers, and then we might be able to kind of bring some of this code back to the left side of the screen a little bit. So how can we do that? Let's think. So let's create a variable called something like all customers. And if we want to take the employees and transform those employees into lists of their customers, that sounds like a map operation, right? So let's try map and see what happens. So we can say Amsterdam employees, map, and that's a function that takes a employee, and we want to return that employee's customers. So let's dump that out and see what we have. So now we get an array that's 6 in size again, which is kind of suspicious to me because we only had 6 employees. And you'd think that employees would have more than one customer each. But if you look inside, this is a collection of 6 collections where each collection is made up of customers. So rather than getting one big list of customers, what we actually ended up with was a list of lists of the employees' customers, right? Which is not quite what we need. So how can we solve this problem? Well, there's another array operation that we can talk about here called flatten that lets you take an array of nested arrays or a collection of nested collections and flatten it down some arbitrary level. And Laravel's collection class provides this method for us and lets us parameterize the level to which we want to flatten it. So by default, if we just called flatten on this list of customers, it would flatten it recursively all the way down to the bottom, which is not always what you want. But we can just pass 1 as an argument, and it's only going to flatten it 1 level, which is going to bring us just this big list of customers. So if we refresh this now we get an array that's 37 in length. That's all customers, right? Perfect. So if we set all customers to be this, so we'll flatten it right at the end here. We can get rid of this dump. And now, it looks like we can get rid of this loop that's looping over the employees, right? Because the only reason we needed to loop over the employees was to loop over their customers. So we can get rid of that, get rid of this, bring this out another level. And now instead of customers, we'll call it all customers, since that way we named our new variable. And if we didn't make any mistakes, when we refresh the browser, we should be back to our $2.9 million. Cool. So the code that we've got down here is already starting to look, quite a bit simpler than this thing, monstrosity. So what's the next thing that we want to do here? So let's kind of figure out what this code is doing. So we're looping over all the customers. We're initializing this customer total sales to 0. We're looping over all of a customer's orders and adding the value of those orders up and building that up in this customer total sales variable. And then we check to see if the customer's total sales are greater than or equal to like our threshold here, which is 75,000. Then we include that customer's total sales in the total revenue that we're building up and ultimately returning, which we initialized up here. So it sounds like this might be easier if instead of having to iterate over all these customers and then get that customer's orders and add them all together and then filter out the ones that are not meeting our threshold, if we just maybe had a list of the total value in orders that each customer had placed. So if we could somehow take this list of customers and transform that list of customers into a list of the dollar values that that customer had spent with us in total over the, the life cycle of this report or the date range that we're checking this in. So that kind of sounds like a map operation again, right? We want to take the customers and we want to map those customers into the total amount of money each customer spent. It's like a one-to-one relationship. So let's try and do that. So let's create a new variable. We'll call it something like customer totals. And we'll take all the customers and we'll map those customers. So we're going to have a map function that takes the customers and arguments. And then we got to figure out what we're going to do in here. So maybe the easiest way to do that to get started would just be to kind of copy this code out of here and see what we get. So we're going to initialize customer total sales to 0. We're going to iterate over that customer's orders, add that up. And then if we return that customer total sales, with any luck when we dump this, we should get a collection of the values that that customer has spent with us. So we get a collection that's 37 long again, which is a good sign because we had 37 total customers. And if we check, it looks like, yeah, these look like reasonable numbers. We won't know till we get a little bit further in the process here, but it looks like what I would expect. It's 37 numbers that looks like it represents the total amount that that customer spent with us. So now that we have that, well, let's keep that there for a second. I don't really like what this code looks like, right? We're trying to get rid of loops. We're trying to get rid of temporary variables. That's not what we're really doing here. So how can we simplify this kind of inner set of loops and stuff like that? Well, let's think about it. So we have customers who have orders, and each one of those orders has a total, and we kind of want to add all those totals together, right? Well, it would be easier to add the totals together if we just had a list of all these totals. So why don't we map the orders into their totals? So we could say something like order totals equals customer orders map. Let's make some room down here. This is going to take a function that takes an order, and now we want to return that orders total. And now that we have a list of order totals, we just have to figure out a way to sum up these order totals. Now, what we're really trying to do here is take this list of order totals and reduce that down into a single value. And there's an operation that the collection provides us that's a standard functional kind of array operation called reduce. It's kind of a confusing one, but it will let us reduce this list of values down into one single value. So if we call reduce here, let's do it in a new variable. We'll say total order value equals order totals, reduce. Now reduce takes a callback that takes a value that we're kind of accumulating, that a lot of people call the accumulator. In this case, because we're kind of trying to figure out what the total order value is, a lot of the time what I'll do is I'll just use the same variable name here. And then it's going to take that individual order total, and then whatever we return from here is what gets passed to the next one and how it kind of builds up. So this is kind of a confusing one. I'll show you how it works, but then I'll also show you how we can simplify it a little bit. So here we want to return the current total order value, whatever it was when we were looking at the previous item, and we want to add that to the order total of the current one. And we need to say that we want to start with 0 as the initial value that we're accumulating from. And with any luck, if we dump this total order value, hopefully we don't get some weird error because I made some silly mistake. So there's a number that hopefully represents the total amount that some customer spent with us. Now, because this is such a common use case for reduce, like using it to add up a bunch of values, there's actually a shortcut for it called sum, where instead of using reduce directly, we can just call sum, which is behind the scenes sort of implemented using reduce essentially. And if we dump this out again, hopefully we see a familiar value. And it's the same thing. Now, in our efforts to get rid of temporary variables, we can use our inline temp refactoring again to take this code here, replace the order totals with that code, dump this out, and we get the same value. Now this is still looking a little bit not great. We still got this sort of triangle thing going on here. First of all this code doesn't matter anymore, right? We can just return this directly here, dump the customer totals, and we kind of get what we had before. But we still got that kind of multiple levels of indentation thing going on that would be cool to get rid of. Well, this use case of map, where you're just taking some object and trying to extract one property from that object, is so common that Laravel provides a helper on top of that called pluck. And we can use pluck to just say we want the total. So now we're going to pluck the total from each orders, which gives us a list of order totals, sum those up, and we get the same thing. And now this use case of plucking something and then summing it is also so common that we can actually just pass the string to total. Or to sum, sorry. So we can just say the customer totals is equal to mapping the customers, and then we take the customer and we sum up the total of all those orders, and we get the same thing. Much shorter. So that's looking pretty good. So what can we do next here? Well, now we can change this loop to, instead of looping over all customers, we can loop over customer total as customer total. And all this code goes away, and we can just say, if customer total is greater than our min sales, then our total revenue is going to include that customer total. And with any luck, if we refresh the browser, we're back to our 2.9 million, right? Same answer that we started with, looking pretty good. So, how can we get rid of this code? Well, it looks like what we're trying to do here is filter out any customer totals that are not greater than or equal to our threshold, right? So we can do something like best customer totals equals customer totals filter. And we just have to return this condition here. So return that the customer total is greater than or equal to min sales. And now we have to do this disgusting, horrible thing PHP makes us do, where we use this min sales variable. And let's dump our best customer totals here. And with any luck, this should be a list smaller than 37. So now we have 23 customers that paid us more than the threshold that we were hoping for, right? So now that we have our best customers, our total revenue can actually just be equal to the best customer totals and then sum them up again, just like we did when we were summing up the order totals. All that code goes away. And now we have that 2.9 million that we started with. So we've gotten rid of all of our loops and all of our conditionals, but we're left with some temporary variables. So let's walk through inlining some of these temporary variables. Best customer totals only gets used in one place, so we can take the value of that and replace that there. Refresh the browser, 2.9 million. Customer totals only gets used in one place, so we can inline the value of that as well. Get rid of that. Still get the same answer. All customers only gets used in one place, so we can inline that and get rid of this. Still 2.9 million. And Amsterdam employees only gets used in one place, so we can cut that, inline that, delete that, and we still get the same value. And now one thing I forgot to mention here is that this situation here, where we're mapping something and then flattening it by one level, is also so common that it has its own operation called flat map. So we can just call flat map, get rid of this flatten call, refresh, still get the same value. Total revenue doesn't need to be initialized anymore. The only thing that really matters is this min sales thing. And I think I'd be quite happy to either inline that or use a constant in this case, so we don't really need that temporary variable. That goes away. And we have the same answer. And we only have, at max, one level of indentation. We have, no temporary variables except kind of the setup and ending ones that we were kind of using just to kind of get our initial data and return our value. But in terms of like calculating this value, we didn't need to create temporary variables and build them up and store them or anything like that. So no conditionals, no temporary variables, no loops. It's a lot kind of nicer looking than this code, which to me matters. And we've kind of solved the exact same problem like a totally different way, where now every single step of this can kind of easily be understood on its own. There's no kind of like shared state to worry about. So here, we're doing things like, adding total revenue to customer total sales, which is initialized here and incremented here, and total revenue is initialized up here because that's the scope that it needs to exist in. And here, you only ever have to worry about like, okay, filter, I know what that does, and I know what that gives me at the end. Okay, flat map, that does one discrete thing on its own. It doesn't have to worry about some state here or anything like that. And you just kind of go through every single step in these small, independent discrete steps, and it leads you to this cool functional solution that looks kind of totally different, which I think is really cool. So we got 10 minutes left, so I have some other cool stuff to show you. One thing I would like to mention is that a common thing that people mention to me, and a common thing that I'll even say, is this is kind of the best idiomatic way to kind of teach these principles, right? And some of the cool ways that you can talk about collection operations and stuff. But a lot of people would say this is the sort of thing that you should just be doing in the database anyways, right? You don't want to load all this stuff up into memory and figure all this stuff out. So I want to show you some cool ways that I use collections that are not really related to this idea of taking some big data set and trying to do something with it. More just day-to-day ways that I use collections with even just really small lists of things and things that I do to kind of make my code a little bit more expressive and a little bit more, to me, maintainable and easier to follow. So, a little while back, we got a pull request to Laravel Valet where someone wanted to add support for PHP 7.1, or to at least have PHP 7.1 work with Valet. And the code that they submitted is exactly what I would have wanted them to submit. They just kind of followed the existing pattern that we had set up in the code base, where we're originally checking if PHP 7 is installed, we consider it valid. If PHP 5.6 is installed, that's good. If 5.5 is installed, that's good. So he just added another item to that list. And the same sort of thing down here. And it's just what I would have wanted someone to do, just kind of follow the pattern that we had existing. But when I saw this come in, it really made me realize that there's a better way for us to structure this code. So I want to show you some cool ways that you can use collections in this case. So we're going to do some live refactoring of some real code here. So here's this function that checks to see if we have an installed version of PHP. So the first thing that comes to mind when I see doing something like this with this list of items, I'd like to figure out a way to actually do this with a real list operation. So the first thing I want to do is create a temporary variable here called supported versions. And supported versions is going to be a collection of all the versions of PHP that we support. And now that we have this list of supported versions, one way that you might rewrite the same code is to do something like this, right? For each supported versions as version, if this installed version, return true. And if not, if nothing matches, return false. Right? And if I run our valet tests, it should still pass. Everything's still good. But we don't like loops, right? We want to get rid of loops. So how can we get rid of this stuff? Well, has anyone ever used the inArray function in PHP? Yeah, someone has used inArray. Come on. I know it's the end of the day and people are tired and grumpy and they want to drink beer and eat barbecue, but come on, work with me a little bit. So the inArray function takes some value that you're looking for and then some list of candidates that you're trying to see if that value exists in that list of candidates, right? Collections have a similar function called contains, where I could say supported versions contains and then pass it some value. So I could say does supported versions contain PHP 7.1, and this will return true because it does. Now, the cool thing about contains that makes it way more powerful than just looking for a single value is that you can also look for any value that satisfies some condition that you specify by passing in a callback. So I could say supported version contains some version where this returns true. So does supported versions contain a version where this installed version returns true? And I can get rid of all this code and just return that directly. And if I did it right, installed, what mistake did I make here? This installed, someone know? Oh, I know why. This is actually an interesting talking point. So one of the breaking changes in Laravel 5.3 is that we switched the parameter order to contains, because this is a mistake that people run into all the time. So the contains callback actually takes the key and the value of the array, and you pretty much never need the key, and you always forget that you have to put it first. So that got swapped in 5.3, and we're still on the 5.2 version here. So a common thing that I do is just use a variable called underscore for useless variables that I'm forced to declare that I don't actually want to use. And if we did this correctly now, we get passing tests. Cool. One more thing. We got 5 minutes, so I want to get through one more real quick. The other situation was down here, which starts to look even messier, where we're trying to figure out what the currently linked version of PHP is with Homebrew. So we're basically just going over all these different candidates and checking, if the PHP that we found matches this name, then that's the PHP that we want to return. So what's another way that we could write this? So first, let's take this supported versions thing, because that's something that we're going to need again, and extract that out into a little helper function. Supported versions. And we'll just have this return this collection. And now this can go away, and this just becomes return. This supported versions contains a version that's installed, which is pretty expressive and kind of cool. Sorry? parentheses. That's fine, come on. So still good. If we jump back down to this linked PHP function now, how can we kind of do this in like a listy way, right? So if we wanted to do something in a more array sort of style, we might implement it with a loop and this sort of thing, right? We might do something like for each this supported versions with parentheses as version. And then we basically want to do like this thing. This gross stir pause is like the worst function ever. So instead of just hard coding PHP 7.1 there, we can say version. And if that does not equal false, then we want to return that version, right? And if none of those match, then we want to default to throwing this domain exception. Run those again, still good. So we don't want to do this with loops, we want to do this with collections, right? So what are we actually trying to do here? If we were trying to describe this in like a more expressive way, to me what we're trying to do is find the first supported version where this ends up returning true. And the collection has a first method that takes a callback that lets us do this sort of cool thing. So we could say something like linked version equals this supported versions first, and first has that same stupid API that takes this unused variable. And we want to return the first one where this condition, is valid. And we're going to need to use the resolved path. Now, the only thing that kind of sucks about this solution is that down here now, we have to do something like if linked version is null, throw the exception, right? And if not, return the linked version. So it's still kind of cool that we can use first this way, but this part's sort of grim. Now, let's run the test to make sure I'm not totally messing things up again. So the cool thing about first is it lets you specify a default, right? So if it doesn't find any that match that condition, you can say return this instead. You can do that by passing some value here, some default. Like maybe we want to say, if no versions of PHP are installed, pretend PHP 6 is installed. Doesn't make any sense, but like that's the sort of thing you could do. It's not really helpful in this case, though, is it? Because we don't have like a default that we want to return. Instead, we want to throw this exception. Well, something cool about the default parameter here is that it can also take a callback that's lazily evaluated. So say that you wanted the default to be something that was expensive to do, like some database query or something. You could put that here, and it wouldn't get run unless the default was the only option to return. A cool trick that I haven't seen many other people do here is that you can actually just throw this exception in there. Who gives a shit? And now this goes away. And when it executes that callback, it's going to throw that exception, and we can get rid of all that if statements and temporary variables and stuff, and just return that right away and just throw that exception if it doesn't find anything, and it's still good. So I thought that stuff was important to cover because I think it's a more realistic use case of like how I use collections in my day-to-day programming. People always ask me questions like, aren't you worried about performance? You're doing multiple loops, or you have all these big data sets in memory, blah, 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 blah. And it's like, if you're actually using them that way, then maybe that's a problem. But most of the time, I'm just using collections to be able to write more expressive code that lets me use operations that exist on the collection to express the things that I'm trying to do in kind of a more object-oriented way. And so here's an example, I guess, of how I use collections most of the time and some of the cool little refactorings that you can do with them, as well as hopefully what was a useful introduction to functional programming thinking in general, as well as kind of teaching you how to think about how higher order functions can help you create more powerful and useful abstractions in your code. So that's all I have. One thing that I did actually want to mention, I don't want to sell it too hard, but if you enjoyed this and you want to learn more, I wrote a book and released a set of screencasts covering more of this stuff. There's a 25% off coupon for people who attended the conference if you want to check it out. So there's a bit.ly link. It's called Refactoring to Collections. It's either at that link or at adamwathan.me/refactoring-to-collections. And I also host a podcast called Full Stack Radio that if you haven't checked out, check out this sick animation. Love Keynote. If you've never checked it out, you should. I get to interview lots of really smart people. I've had like Michael Feathers on there talking to me about collection pipelines. I've interviewed Kent Beck. I've had DHH on there twice. I think he's the coolest. I don't know about you guys, but it was pretty awesome. So yeah, that's been pretty awesome to be able to do that. And if you're interested in hearing discussions with people about that sort of thing, check it out. And yeah, I'm Adam Wathan on Twitter. My website is adamwathan.me, where I blog about object-oriented design and testing and stuff like that. And if you can rate the talk on Joined In at that link, I'd love to hear any feedback that you have. And thank you, and I hope you had an awesome time at Laracon EU.